So for today's lesson, we're going to go over how to add forces together utilizing vector addition. But before we go ahead and get into adding them together, first I want to review how to break down forces or vectors in general into their components, because we're going to need to be able to do that in order to go ahead and do vector addition. So the first part would be breaking forces or vectors into their components. So this is also sometimes referred to as resolving a vector. So let's go ahead and start off with some value. Let's go ahead and give this a force equivalent to 10 newtons. And let's give an angle to this. Let's go with 20 degrees. What we need to do is break this force into its components, the x component and the y component. So first we're going to go and we need to get an f of x, and we also need to get an f of y. To get those values, we're going to go ahead and use some trig functions. For the y component, that is opposite of our angle, so we're going to be using sine, and the x component is adjacent to the angle, so we'll use cosine. So to get f of y, we'll do f sine of theta. So that will be 10 sine of 20. We're doing these in degrees, so make sure that your calculator that you're using is in degrees and not set to radians. That value should come out to 3.42 newtons. Now also need to do our x component. Use cosine function there. And that one will come out to 9.4. Okay, so now we're going to go ahead and get into some vector addition with forces. So to start off with, I'm going to go ahead and just draw an x and y axes. Draw in our force values, and then go about first resolving the vectors into the components, and then actually doing the vector addition. So the first force, we're going to make that one 8 newtons. We will call this F1. That's going to be at an angle of 60 degrees. Our other force is going to be F2, which is going to equal 9 newtons. We're going to do that as 65 degrees. Now, with both of these forces, we're doing the resolving part for it first. So we need to get to an x component here. We need an x component here as well. Now, since we're measuring this off of the y-axis instead of the x, I'm going to draw the x component along this line here. Then we need to also have our y component. For each of these. And now we need to go ahead and get the values for those. So starting off with, we will do the x components. So we'll start off with F1. So force 1 x component is going to be F1 cosine of theta. So we get 8 cosine of 60 which ends up being 4 newtons. Do the same thing for F2. So F2x would equal F2. This time it's going to be sine. The reason it's sine is because that the angle 60 is opposite of where this f of x is. So it's not going to be adjacent like this one, but opposite. So we need to swap our cosine function for sine. So 9 sine of 65. Now if you wanted to stay with using the cosine function, then what you could have done was, instead of using 65 degrees, you could have switched over to 25. All right. And that would have been looking at this angle here instead, and you'd have written your x component along this edge and your y down here. Get the same values, the triangle is just going to look a little different. So now we have our x components. Let's go ahead and get our y. So f1y would be f1 sine theta. That one comes out to 6.93. And then f2 is going to be f2 cosine theta. So 9 cosine 65, which is 3.8. So now we have our components. Now what we need to do is figure out our net forces now that we have the components. And to figure out the net forces, we're going to do them by component. So we're going to find out the net force in the x direction and the net force in the y direction, and then create a triangle utilizing those net forces to then find the total net force. So working in backwards of what we've been doing currently. So to start off, we'll do our x's. So we're going to figure out sigma fx, the net force in the x direction. It is going to be f1x plus f2x. Now in this case, we have forces acting in opposite directions, so we need to assign positive and negative values. So we're going to say anything in the positive x direction is a positive x, positive y direction is positive y. So in this one, that means f1x is going to have a positive value, f2x is going to have a negative value. So it's going to be 4 minus the 8.16. So we get a negative 4.16 as our net force in the x direction, which means that our net force just means it's acting to the left overall. Now we need to figure out Fy, so the net force in the y direction. So F1y plus F2y. F1y is the 6.93, that's in the positive y direction. And the 3.8 is in the negative. Sorry. Took a minute for that to process. All right, negative 3.13 newtons. So we have a positive 3.13. So we have 3.13 newtons and negative 4.16 newtons. If we want to draw that out, we would have try and get some values here. Change the color up. So we're going to draw our y component here and our x component here. So we have a total net force in the x direction of negative 4.16. And then we have a y component of 3.13. The total net force that we're looking for is from the origin to here. F net or sigma F. And we would also need to know the angle here as well, which way is it going. Okay, because remember, force is a vector quantity. You need a magnitude and you need a direction. Now that F net is just the hypotenuse of a right triangle that we just made. So to find out the magnitude, the net force, let's go with Pythagorean theorem. So we get negative 4.16 squared and 3.13 squared. Let's just jump right to the answer there. Because sigma F ends up coming out to 5.21 newtons. So there's a magnitude. Now to get the direction, I'm going to use inverse tangent. So y over x. So 3.13, 4.16, and 36.96. So our total net force then ends up being 5.21 newtons at 36.96 degrees. So the process to that whole thing is, first, you always want a diagram. To resolve the vectors. And that's the part you break it into components. 3, you want to calculate the net components. So you want to calculate F net of x and F net of y. And go ahead and find the total net force and the angle. How would you state your answer at the end? Just say F net equals 52.1 or 5.21 newtons at 36.96 degrees. And you could say that's above the negative x-axis. You could also go from the positive x all the way around. So use a total angle, which would be 90 plus 52.14, so 142.14 or 04 degrees. Okay, either one of those is a viable answer, and that's it.